Depending on where you live in the UK, you've either had 3 weeks of warm sunshine or you've had 3 weeks of cold easterly winds and extensive cloud cover. That contrast captured very nicely first few days of June here. This is the maximum temperature anomaly. Well above average maximum temperatures in the west, well below average temperatures in the east. But things are finally about to change. Over the next few days, we're going to see humidity levels increase. We're going to see temperatures increase in many, but not all parts of the UK. And as that happens, we're going to see the risk of showers and thunderstorms increase. How hot will it get? Where will the thunderstorms occur? And will we finally lose that nagging easterly wind? I'll try and answer those questions in the next 20 minutes or so. This is the Met Office Deep Dive, an in-depth look at the UK's weather for the next few days and beyond. Thank you for joining me. And of course, we always remind you at this point to subscribe to our Met Office weather channel if you can, because then you won't miss these in-depth reports. And of course, we've got the 10-day trend on a Wednesday, and we'll have further updates through the next few days about the weather this weekend, because things are looking potentially quite tasty heading into the weekend, following several weeks of very little happening. And in fact, over the next couple of days, very little happens. Here's the bigger picture. You're probably very familiar with the overall setup by now. We've had this dominant blocking high really affect our UK weather for the past 3 weeks, if not longer, since the middle of May, since we saw effectively that horrendous flooding occur in the southwest of England, some very serious thunderstorms around the middle of May, and then this high pressure developed across the UK, and then it sat to the north of the UK during the last few weeks. Now, of course, when high pressure sits to the north of the UK, we get this easterly airflow, and in the spring, it's not uncommon to have high pressure sitting to the north of the UK and an easterly airflow. It's often at this time of year that we get these blocking patterns, but it's been particularly stubborn this spring and early summer. And with that easterly airflow, we've had this suppressed temperature feel along the North Sea coast, 11 to 14 Celsius on the North Sea coast during the last few days and weeks, with extensive low cloud coming in from the North Sea. But in the west, as you saw from that map at the beginning, much higher temperatures, low to mid-20s now this week in the west with the warm sunshine. However, through Tuesday, we have seen more extensive low cloud across central parts of the UK. Certainly it's been slower to burn back to the east coast, so I suspect if you're in the Midlands, if you're in East Wales, you'll have a sense of what it's been like for the North Sea coast through the week and further back than that. Now, there are some changes currently taking place. This over here is Storm Oscar, currently bringing some unseasonably unsettled weather to the Canary Islands, to Madeira, to the Azores, very wet and windy in places. This, by the way, these arrows here, this is a filament of the jet stream, and what you can see actually is it's effectively the blocking pattern over the UK, with one branch of the jet stream pushing well to the north, that has caused part of the jet stream to push well to the south, which has in turn formed this area of low pressure, Storm Oscar, named by the Spanish because of those wet and windy impacts for Madeira. Now, it's going to slowly approach the UK over the next few days, not necessarily bringing storm-like conditions to the UK. It doesn't really get close enough, but it will eventually introduce subtle changes in our weather. So I'm just going to play this forward, and what you can see, actually, the two L symbols here, we've got two areas of low pressure. They're dumbbelling around each other, and this sometimes happens before one of them gobbles up the other and takes over as the main low. Now, when that happens, computer models find it a bit tricky because it's quite a complex setup when you've got two areas of low pressure dumbbelling around each other. And that introduces uncertainties as we head into the weekend. Not major uncertainties, the general themes are fairly certain. We're quite confident that the winds will subtly change, that some areas of the UK will turn significantly warmer, and that we'll see higher humidity as the wind direction changes, as that X-storm approaches the UK. It allows high pressure to push more to the northeast and then the east of the UK. And let's just pause it there. What time is it? It's Friday, late Friday, and that's really when the changes start to be felt across the UK. So very similar weather patterns over the next couple of days, with that general easterly airflow, low cloud coming in by night, retreating back towards the east by day. I think a bit more sunshine widely on Wednesday compared with Tuesday, but similar sorts of themes over the next few days. Wednesday, roughly the same as Thursday. We are going to see a general uptick in temperatures. I'll talk more about that in a moment, but really it's into Friday and the weekend that the more significant changes take place, because that's when Storm Oscar, or the X-storm, as it is, this low pressure approaches from the southwest. We've got high pressure to the east of the UK, and as a result, rather than high to the north and low to the south and this easterly, we've got more of a southeasterly for eastern parts of the UK and more of a southerly or southwesterly. Let's zoom in there so you can see it a bit more clearly. More of a southerly or southwesterly for the south and southwest of the UK. And that's why humidity is going to increase, because the winds no longer coming in from the North Sea, they're going to come in from towards the southwest, and that is a more humid wind direction. And as a result, temperatures are really going to shoot up in some parts of the UK where those temperatures have been suppressed, namely Norfolk, Suffolk, Kent. We're going to see a really, really significant jump in temperatures by the start of the weekend. And it does somewhat depend on the position of this low pressure, and the position of the low pressure by the weekend depends on the precise interaction of the various low pressure systems that are dumbbelling around each other over the next 24 hours or so. So there's an element of uncertainty this weekend, both in terms of where we see the highest temperatures and highest humidities and what those values will be and when they'll peak, but also any thunderstorms, because at the same time as temperatures rising and the humidity rising, remember it's been bone dry across most of the UK for the past 3 weeks, we're going to see the chance of showers increase and even the chance of some thunderstorms. You can see some occluded fronts here. Oscar bringing not only an increase in humidity but also bringing lower pressure, so rising air, and from the southwest on Friday, and more especially across much of the UK into Saturday and Sunday, showers and thunderstorms are likely to spread northeastwards. They're not going to affect everyone. I'm going to show you some of the differences in the different computer models in just a moment, but there is that increased risk into the weekend. But let's look at temperatures over the next few days first of all, because really it's quite significant how those temperatures are going to change. In fact, let's take a closer look at the UK here. Now, these are the maximum temperatures, and actually it's been a coolish day today because of the low cloud more extensively across central and eastern parts of the UK. 12 to 13 Celsius on the North Sea coast, that's it. Then into tomorrow, a bit higher there towards the southwest, and I'm just going to zoom in first of all into the southwest because that's where the changes are most likely to start to occur. Temperatures rising, it's this part of the UK over the next few days, Wednesday, Thursday, Friday, which will likely be the warmest part. So let's take a look at how those temperatures change. I think into Thursday, we're going to see widely low 20s, perhaps 24 or 25 Celsius. And you can see a 25 coming up there for Southampton on Friday. There's a potential for 26 or 27 on Friday. And then heading into the weekend, actually into the weekend, those temperatures are lower a bit towards the southwest because of the additional cloud coming in ahead of the low and the risk of thunderstorms. But let's move over to the east here, and you can see what a difference for Norfolk. Low 20s, mid 20s in places for East Anglia, and the potential, you can see London there, 26, the potential for even higher than that, high 20s possible. In fact, we'll just quickly run through that using my magic pen here, and I could just scrape it across the map here and show you that is quite a remarkable jump in temperatures for North Norfolk. As those winds change direction, we've had this persistent North Sea wind during the last few days and weeks for Norfolk. I know it's been miserable there, but look at that, 13 degrees on Tuesday, 16 or 17 on Wednesday, 25 on Saturday. I mean, that's quite a remarkable jump in temperatures by the start of the weekend for eastern England. It's just a change in the wind direction, boom. You've lost that easterly. But it's not going to be a change like that for all of the east of England. I'm going to just run up the coast here. The further north you are, the more likely you are to keep some of that cooler feed. Although still, north of Newcastle there, you've still got 21 Celsius coming out of the model on Sunday. It just takes a bit longer. It takes much of the weekend for those winds to change direction. And for parts of eastern Scotland, it doesn't really warm up. I think we're going to keep the low cloud. We're going to keep that North Sea wind into the east of Scotland, whilst much of the east of England eventually sees that change in wind direction by the end of the week and the weekend. And so much cooler, far northeast of Scotland, but you can see that tremendous jump in temperatures as you go further south. Kent as well there, up into the low 20s. London up into the mid-20s. And somewhere around probably Cambridgeshire, likely to be the warmest spot into the weekend. Mid to high 20s possible. You know, you could call it 28, 29. These are values straight from the Met Office global model, but, you know, looking at all the different factors and all the different models, there is the potential on Saturday for temperatures in this part of the world. So for somewhere around Cambridgeshire to reach the mid to high 20s, 28, 29 possible. Most likely peaking on Saturday. Towards the southwest, actually, it's a different story. Temperatures get lower into the weekend because we've got that increased risk of showers and thunderstorms. Now, not only have we got that change in temperatures, we've got the change in the humidity and, as a result, the ingredients there to produce some lively storms. And what I want to do, because I mentioned this in the previous deep dive, I've talked about Tephigrams. These are graphs of the atmosphere all the way from the bottom up to the top of the troposphere, where the where aeroplanes fly, where the jet stream is. And we send up weather balloons each day, and they measure the temperature, the wind speed, and the humidity from the surface way up to 30, 40,000 feet or so. But not only that, we run the computer model, and that gives us an estimate of what the weather balloons will be saying on a particular day. So we can take these, what they're called Tephigrams. The T in Tephigram is for temperature, the phi is for entropy, the Greek letter for entropy, and then gram, obviously a graph. So it basically gives us a lot of information about the profile of the atmosphere, the temperature, the humidity, and the energy available for thunderstorms. And just to quickly show you what I mean by all of that, the graphs are essentially, we've got along the bottom there, that's the surface, and then we've got the height going up there. So this is a profile of the atmosphere. Now the temperature, as we all know, goes down as you go higher up, not in a uniform line, it varies depending on the weather, but the temperature goes down. Now, what we do is we mark the temperature lines diagonally across the map there. So they say that's 0, that's 10. For example, that's 20. The reason they're diagonal lines is so that the graph isn't too leant back. Okay, so it's easier to visualize how the temperature changes with height. If the lines were parallel with the surface, then, well, it would be really difficult to read. It would be leant back. So the lines are like that, and then the weather balloon goes up from the surface, and it basically wiggles like this, and it goes up like that. And that's how the temperature is changing through the atmosphere. So it goes up 20 and then 10 at some point, and then 0 degrees, depending on the weather situation. You've also got the humidity. This is measured by the dew point, and that goes up as well. Now, the closer the dew point is to the temperature line, the more likely you've got clouds, the more humid, the more saturated the air is. Not only have you got these two lines, but you can figure out how much the air is going to rise on a particular day by comparing the rate of rising air with the temperature of the atmosphere. Now, whenever the temperature of a bubble or a thermal of rising air, whenever that's warmer than that red line, it's going to continue to rise. But when it cools down enough so that it crosses that red line, it stops rising. And that's how we know the height at which cumulus clouds or cumulonimbus clouds will form. We can put this imaginary thermal onto the graph. And the way that we do that is we know that if you heat up a parcel of air at the surface, then it will cool at a rate of about 10, it's actually 9.8, but let's say about 10 degrees per 1,000 meters. So that's the rate at which it cools until it gets saturated, the point at which it forms clouds, 100% saturation. And then it cools at a slower rate. And that's because as it's saturated, it's condensing, and that condensation releases energy, which stops it from cooling so much. So what we can do is we can say, okay, the line here, let's say that the air at the surface was heated up by up to 20 degrees, then it will cool at that rate of dry air, and then it becomes saturated, and then it cools at a slower rate like that. But all the time, it's to the right of that red line, then it's going to continue to rise because it's warmer than the air around it. Then at some point, it goes behind the red line and it stops rising. Then we know that's the base of the thunderstorm, that's where it becomes saturated, and that's the top of the thunderstorm. The reason I show you all that and explain it all is because I explained it badly in a previous deep dive, so hopefully that's made a bit more sense, although that looks terrible, to be honest. But also because there are some cool Tephigrams to show you here for the weekend, and they show the potential for thunderstorms really nicely. So what we've got, same sort of thing that I just drew very roughly. We've got the black line here, and this is for the southwest midday on Friday. We've got the black line in the middle there. That's the temperature that you imagine might be measured by a weather balloon if it's released in the southwest around lunchtime on Friday. Then that's the air. If you say warm up the air at the surface to 24 Celsius, then it goes up. It reaches saturation, we can tell. It reaches the dew point temperature, reaches saturation at a height of about 5,000 feet or 1,500 meters. So we know the base of any thunderstorms are going to be about 5,000 feet, 1,500 meters, quite high up. And then it will continue to rise in that cloud. That cloud will continue to bubble up. So that's the base of the thunderstorm. And it continues to be a thunderstorm all the way up to virtually the tropopause, the top of the troposphere, 30,000, 35,000 feet high. So that shaded area, that effectively gives us our thunderstorm. So what we know from that is thunderstorms are likely because the air temperature, what we measure in a weather balloon, is decreasing quickly, and that means it's lent that way. And so you've got the cooling rate not really managing to keep up with that. And so you've got constantly rising air all the way up to the top. So we know the height of the thunderstorm at the base and at the top, so it's going to be quite a vigorous system. And then very similar situation for Saturday, West Wales here and southeast England here. So what we can deduce from these are that, and basically the more shading you've got here, the more energy in the system. So for southeast England, there's more shading on the graph, and that means there's even more energy available. And that is because there's higher humidity and higher temperatures. We've got a temperature of 28 degrees. So if you get a temperature of 28 degrees in the southeast, which is entirely possible, you get these whopping great big thunderstorms. Again, they're high-based thunderstorms, 5,000 feet or so. And that's important. So we know the height of the base, which is important because that would indicate how much rain we're going to get. Now, the higher the base, the less rain you get out of them because the rain's evaporating as it falls into drier air below. But this shows a comparison from 4 different computer models of amounts of rain through Friday and Saturday. So Friday and Saturday combined amounts of rainfall, and they are showing some significant amounts of rainfall, falling onto dry ground, of course, in many places. This is the high-resolution UK Met Office model, and it shows mostly it's across, say, southeastern parts of Northern Ireland into southwest Scotland, western parts of England and Wales, and it's showing in places 20 to 40 millimetres. And then likewise, very similar, the Met Office global model, lower resolution there, southwestern parts as well as Wales. More widely for the European model there into central parts as well as central parts of Scotland, but you can see some brighter patches and some less bright patches. So sporadic nature of these showers and thunderstorms. Not everyone will experience them. On Friday, chance in the southwest, elsewhere not really. Into Saturday, it's many other central and western areas, but again, they'll be hit and miss. And this is the American model. It's got it more widely into eastern England by the end of Saturday. Sunday, I think they'll make further progress northeastwards across the UK to affect, say, parts of eastern Scotland as well. But I think the greater rainfall amounts would be possible if the base was a bit lower. As it is, the rain is likely to evaporate a bit. And also, the hit-and-miss nature of the thunderstorms means that in some places you could see, say, 40 millimetres in a couple of hours. In other places, very little rainfall. And at the moment, because of the dumbbelling lows around Storm Oscar and because of the complexities around that area of low pressure that approaches the UK, well, it's just simply too far ahead to predict exactly where we're going to see thunderstorms. But as you saw from those Tephigrams, from those graphs, there's certainly the potential, there's that energy in the atmosphere, the instability in the atmosphere to cause these storms. And just before I finish, what's going to happen beyond the weekend? We've got the increased humidity, we've got the increased temperatures, apart from, say, for eastern Scotland. We've also got that thunder risk. And beyond that, well, first of all, let's take a look at the temperature anomalies from the European model for this week. This is Monday to Monday next week. And this shows quite clearly that east-west splits with warmer than average temperatures there for the west, cooler along the east coast. But the same sort of thing for the following Monday to Monday. So this is much of next week's weather. You've again got the higher temperature anomalies in the west, but also the east higher than normal. So likely eventually after this weekend to warm up across the UK, but again the warmest conditions relative to average likely towards the west, Ireland, western Scotland, Wales and the southwest. And this warm anomaly is signalled in many of the computer models through the rest of June and into the start of July. Why? Because this pressure pattern is signalled for the same period of time. What we've got is higher pressure anomaly towards the north and the northeast of the UK. But this time, rather than low sitting to the south with an easterly airflow, we've got low pressure sitting to the southwest. And that subtle change allows more humid and warmer conditions to be drawn up from the south and especially the southwest. And that's why we're going to see warmer than average conditions throughout much of next week, especially towards the west. And I wouldn't discount the risk of further showers and thunderstorms at times, especially in the south because of that low pressure being a bit closer. However, plenty of fine weather in between any showers and thunderstorms, so it's not going to turn desperately unsettled either. And of course, for the day-to-day detail, we'll be keeping you updated right here at the Met Office. Thank you for watching, and just a quick reminder, probably expecting this, to hit subscribe, hit like, and leave us a comment. Love reading your comments, and we've got a list of suggestions from people's comments as well about what to cover in future deep dives, which we'll get around to at some point, maybe when the weather becomes less interesting, if that ever happens, of course. Thank you very much, and yeah, that's all from me. Bye-bye.